Okay, so this video is going to introduce us to the first topic from Chapter 7, which is integration by parts. And Chapter 7 is about learning some more integration techniques. So we can only integrate a very few things right now, because we have sort of the fundamental theorem of calculus, we can do basic antiderivatives, we can do some basic algebraic manipulation to get to something that we know how to integrate, or we can do substitution. And that doesn't integrate hardly that many functions at all. And so we have to develop some more techniques to integrate more complicated functions. And so we have the substitution rule, which is related to the chain rule. And now we're going to try to figure out a way to undo the product rule. So if you remember the product rule, you have a u and a v multiplied together, so two functions. If you take the derivative of that, you get the derivative of the first times the second, and then plus the derivative of the second times the first. So that's your product rule, hopefully you remember, from Cal 1. And so now the idea is if we integrate sort of both sides of this, so if we sort of do the integral of this with respect to x and the integral of this with respect to x, we kind of turn that into, I'm going to get rid of the of x's because they're just kind of a mess. The integral of uv dx is really just the integral of u prime v dx plus the integral of v prime u dx. And if you rearrange this a little bit, and uv prime, so if you integrate the derivative, so integrate the derivative, this would just be uv, and then that's the integral of u prime v dx plus the integral of v prime u dx, and it doesn't really matter which one of these you solve for, but the equation that we often do is solve for this guy. So we get the integral of some derivative of one function times another function is really just the two functions multiplied together minus, if you bring that over, u prime v dx. So this is sort of where this integration by parts formula is derived from. It's really thinking about the product rule and undoing that. And so the integration by parts formula is you're trying to integrate some function multiplied by the derivative of some other function, and you'll get back sort of use this formula, right, to get to the opposite of the product rule. So we are going to need to do two things. We're going to need to choose a u and a v prime. We need to think about what's the best way to choose those things. How do we make that decision, right, about what is u and what is v prime? So that's what we're going to try to do now. Okay, so when choosing a u, there's this sort of abbreviation. I don't know if it comes from your book or from a book I'd used before, but there's like this LIATE. So it's not even like a great abbreviation because it's like Liat. I don't know what word this is, but it's something. So I guess you can use that. But you want to choose a u so that u prime is simpler. Than your original u. And in particular, this Liat stands for log, inverse trig, algebraic, trig, and exponential. So things that are pretty complicated to begin with, whose derivatives might be less complicated. Those are the things that you might want to choose for u. And then a v prime, should be a v prime here, I don't know why I'm missing the prime part. You want to choose a v prime so that the integral of v prime dx can be evaluated. So don't choose something that's hard to integrate, and usually it's something that can be evaluated easily. So generally you want to choose a derivative, your v prime, as something that is really easy to take the antiderivative of. If you have a really hard integral to calculate, then you're going to be spending quite some time trying to integrate that integral and never actually get the answer to your full integral. So that's kind of our idea. So we're going to work one example here in this video, and then we'll work quite a few more in class just to practice and look at all the different possibilities. So the example in this video we're going to do is this integral of x e to the negative x. And the first thing you want to notice is this is certainly not a u substitution, because if you let your u be the thing in the exponent, you're still going to have an extra x sort of left on the outside. And it's not a basic integral. And so that certainly means that integration by parts, this IBP, is the way you want to go. So you sort of have two options here in terms of you need to have a u and you need to have a dv, or a v prime. I like to do u and dv, but that's totally up to you. So u could be x and dv could be e to the negative x. Or the other option is that u is e to the negative x and dv is x. And so it's up to you to try to think about which one of these is really the best and the easiest way to do this integral. So if you think about this u, taking its derivative is obviously very easy. And it's actually something that's simpler, right? And that's the kind of idea, is you want to let u be something that's simpler. Over here, u e to the x is an easy derivative, but it doesn't really give you a derivative that's easier. It still makes things complicated. And when you integrate this is actually going to get more complicated as well. So your idea, if all possible, is to have a u that's going to make things easier. And I think in this case, this one over here, the first one is going to give us a du that is simply 1 dx, and it's going to give us a v of negative e to the negative x if you integrate that. Right, you have the u substitution a little bit in your head. So if you integrate e to the negative x, you'd get e to the negative x, and then you multiply by that derivative of the constant there. Okay, so now you have, I'm sorry, this is v. So we have v, we have du, we have u, and we have dv. And so now we just use that formula. So as a reminder, the formula is u times v minus the integral of v du. Okay, so now we're just going to take this, so it's u times v, so it's generally like this little cross this way, so it's kind of here. So x, e to the negative x, there's also a negative there, one right here. So negative e to the negative x, and then minus the integral of v, which is negative e to the negative x, and then dx is our d. And so now you just need to evaluate this, so you get negative x e to the negative x plus the integral of e to the negative x dx, and then for this negative x e to the negative x, this integral you've already done, so it becomes negative e to the negative x again, and this is where you finally put on your plus c. So there are some plus c's that are kind of hidden here in your integration by parts piece, but because they're just constants, we end up just adding on one constant towards the end. That's this constant here. And then we get our final answer for integration by parts for this first question. So we're undoing the product rule. We're thinking about finding a u that gives us a nicer derivative when we take its derivative. We're trying to find a v that's integratable. And then we kind of just use this fancy formula, plug stuff in, and then see what we get. We'll work plenty more examples in class on Friday.